Hello, this is John Baugh again with your third session for C++ programming, CIS 2252 for the summer session. First we check our syllabus because it's the best place to start to make sure what we have going on. So today is for the lecture for the 20th, even though I'm recording it on the 15th. We're covering control statements, part 1, and this is in chapter 4 in your book for the Deedle book, the 9th edition. So chapter 4 introduces you to control statements. So first thing we need to do is cover what is an algorithm. So we've kind of briefly explored how to solve problems. So we have to give a formal definition to what is an algorithm. So an algorithm, a formal definition for an algorithm would be a well-defined, finite, ordered set of steps for solving a problem. So as far as an algorithm is concerned, it's well defined, meaning it's unambiguous. You can't use unambiguous language when telling a computer what to do. When programming software, you can't just say, literally say do this, do that. You have to be more specific with what you want done. So you have to have a lack of ambiguity. So in that sense, an algorithm is well defined. It's finite, meaning that even though it may take a long time, it might be a very intensive algorithm. It's finite, meaning it isn't infinite. So if you end up with an infinite loop somehow, which we'll talk about, then that would mean that it's not really an algorithm anymore. And then it's an ordered set of steps, meaning that the order in which you do the steps does matter. So if I defined an algorithm for baking a cake and you put the ingredients in the mixing bowl and you didn't put the milk in the mixing bowl but you put all the other ingredients and then I put it in the oven and then I take it out and then put the milk in it, you're going to have a mess on your hands. Okay, so the order in which you do the steps for baking a cake and what you put it in, how you do it, matters. So again, an algorithm is a well-defined, finite, ordered set of steps for solving a problem. Or you could say well-defined, ordered, finite set of steps for solving a problem. Doesn't really matter. Ironically, it doesn't matter what order you put the characteristics of the algorithm, so when defining it. Today we're going to go over control structures. That's the major impetus behind today's lecture. And we're not covering all of the control structures that we have in C++ this week. We'll cover a few next week. But there are three different categories of control structures. The first that you're familiar with and you may not even know it is called the sequential control structure. Now that's just when I write code and say do this, do this, do this, and it just does it. So that's basically what we call the sequential control structure. Everything happens in sequence. The next two control structure categories that we'll cover today are selection control structures and repetition control structures. A selection control structure, sometimes known as a branching control structure, these types of control structures are when you have to make a decision between different paths you could take. For example, if a certain condition is true, if the customer has a discount card, then give them the discount. If not, don't. So that's when your program actually has to make a decision. So that's called a selection control structure. You might have a situation where you do something or don't do it, or you might pick between two different options, or you might pick between amongst multiple possibilities based on the particular condition. The third category of control structures is known as repetition control structures, or also known as iterative control structures. Repetition control structures repeat a set of steps over and over again, possibly a predetermined number of times, or possibly without knowing before runtime how many times you're going to do the steps. But the idea behind repetition control structures is just that they repeat. Okay, so the first control structure we're going to look at, specific control structure, is the if single selection statement, or the if single selection structure. Let me create a project. I'll call this session 3, control structures. And to start off, we're just going to start with a main file, console application, empty project. And we're just going to create one source file to start off with, just to explore some of the concepts, and then we'll solidify them a little bit. So under source files, I go to add new item, and then I'm going to add a CPP file and just call it main.cpp. So here's our main file. I'm going to include the iostring library, and then the skeleton for the main function. Okay, so again, the first selection structure we're going to look at is called the if single selection structure. So let's do this. We're going to say int sum num, set it to 0, and then we're going to ask the user to enter a number. So enter an integer. So we prompt the user here and say enter an integer, and then we the program waits on the user to enter that integer, and then once they enter it, now we're going to do something. We're going to say if sum num is greater, we'll say greater than or equal to 0. We'll say user entered a non-negative number, or more importantly, more specifically, we'll say you entered a non-negative number. Otherwise, we don't do anything. Okay, so that's our code. Declare the variable. We set it to 0 initially. We ask the user to enter an integer. The user enters an integer. Then, in this if statement, we have the body of the if statement here with 2 curly braces, just like we have for the main function. The header of the if statement starts with the keyword if, then an open parenthesis and close parenthesis on either side. Notice there is not a semicolon here, and none right here either. Inside the parentheses, we have the condition. So there are many different comparison operators in C++. This particular one happens to mean greater than or equal to. Okay, since we don't have a specific easily accessible key on the keyboard that is greater than or equal to, we just write the 2 separate symbols, greater than, equal to. So we tested here sum num greater than or equal to 0, and then if that is true, okay, this ultimately what this is it's something that evaluates to a Boolean value, so it's either true or false. So this statement, we ask the question, is the number they entered greater than or equal to 0? If it is, it could be 0, it could be 1, it could be 50, it could be 100, or a billion, okay, or, well, 100 million, we'll enter it, we enter the number, and if they do enter a number that is non-negative, it will print out, should be you entered a non-negative number. And then if they didn't, it'll skip over the body of the if statement and then go straight to the return statement. So let's build this and run this. We build it. And it succeeds, so we go to debug and we go to start without debugging. It says enter an integer. Let's put 50. We'll say you entered a non-negative number. we'll do what we call boundary testing. We'll enter a 0, hit enter, and it says you entered a non-negative number. Then I run it again. Debug, start without debugging. Let's enter a -4. And then we just get to press any key to continue because the program terminates after that. And remember that this is entered by the runtime environment, the compiler. It's not anything we're doing. Okay, the IDE adds that. Okay, so that is the if single selection structure, or if single selection statement. It means you either do something or you don't. The next option we have is called the if-else double selection structure. If-else double selection structure. So you can add on to this if statement by putting an else. Right? So this means that it will either do this or this. So if the sum num is greater than or equal to 0, it will do whatever's in this body. If it's not, meaning if it does not satisfy the condition in the if statement, if it's anything else, we do whatever in this body. So we'll say you entered a negative number. So you entered a negative number here and you entered a non-negative number here, so it will make a decision and branch to one of these. So this is a double selection structure because it goes to one or the other. So I'm going to build it. We're going to start without debugging. If they enter a 60, it'll say you entered a non-negative number. If they enter a 0, it'll still say you entered a non-negative number. And now we're going to debug it and say -400. Now this time, instead of just doing nothing, it'll say you entered a negative number right here, because that's what happens in the second portion right there. So that's the if-else double selection structure. So remember, we have 3 categories of control structures. Sequential, which is sort of what this is right here. This is just stuff being done sequentially. You declare a variable, prompt the user, get the input, everything's done in a row. Then you have the selection control structure, the if statement here, the if single selection statement, or single selection structure. This is a selection control structure, or branching control structure right here, if else. This is the if else double selection control structure. If the if was alone and it had no else section, it would be a single selection structure. So those are the 2 selection structures that we're dealing with today: the if single selection structure and the else double if else double selection structure control structure. Also note that you can actually nest these, meaning I could put an if statement inside of here. You can also create what are called else if statements, which I could say else if, for example, sum num less than 0. Okay, this would in this case do the same thing, but you can branch these along. Okay, so if I say, let's say it's we haven't gotten to this yet, but there are compound structures where we can combine these conditions using and. Okay, 2 and signs. I could say if sum num's less than 0 and well, actually, let's do this. This will be a lot quicker. Let's say first we're going to test if it's less than -100. So we'll say you entered a really negative number. Okay, and then otherwise, meaning if it gets to this point, it'll be negative, but it won't be that negative. So you've entered a negative number. All right. So same thing if they entered a number 0 or greater, and then we have an else if that says if enter some num as, say, negative 150, it'll say you entered a really negative number, and then otherwise, if it doesn't satisfy either of these two conditions, meaning it's not greater than or equal to 0, and it's also not less than negative 100, meaning it could be negative 50 or negative 99 or negative 60, it'll get to here. So let's test this. Let's say I enter 100. As expected, it says you entered a non-negative number. Then we're going to say negative 150. So you entered a really negative number, which is what we expect, because that number we entered is less than negative 100. Notice that even though these look like they're sequentially in order here, and it does test them in order, it'll test this one first, and if that one's not true, it'll test the next one. If that one's not true, it'll test the final one. In this case, this is a default because it has no condition here. There's no if statement here. So let's try it with a number that will fall in this range. So let's say negative 50, and hit enter. It'll just say you've entered a negative number. So this is not true. It's some num greater than or equal to 0 is not true. Some num less than negative 100 is not true. And so finally, the only thing left is it's just a regular old negative number. So you might be asking, you might be thinking, well, I've seen it like this before. In a situation like this. So let's say, let's do it this way. Let's have 3 different sections here. Well, so if some num is just less than 0, right there, which is essentially what the else statement meant. So what is the difference between this and what we had previously? Since they're not being linked by the else keyword, the compiler views these, the runtime environment views these as separate single selection statements. So what's going to happen if we enter a negative number that's a big negative number? Let's see what happens. We should have built it first, but it'll always remind you and say, do you want to build it? So I'll enter an integer. If I enter 100, it does what we did before. It just says you entered a non-negative number. If I enter negative 99, it'll just say you entered a negative number, which is this, because this one's not true at that point. But here's what's a little peculiar. If I say negative 150, do you see how it prints out both of these? It says you've entered a really negative number, and it also says you've entered a negative number. Look at why it does that. Since these are no longer linked by an else keyword, when we enter the number, this one's false, this one is true, because the negative 150 is less than negative 100, but this one is also true, since negative 150 is also less than 0. Since we're not linking these, it's not going to exclude either of these. When you link them using an else statement, you're basically mutually excluding the conditions. So if I were to put this and just attach these two, let's see what happens when I enter a negative number. Okay, so let's enter a negative 150. Notice it only prints out the first one because we now have these two linked. Okay, what if I enter negative 5? It's only going to print out the second one. Okay, see how that works? So that's the difference between just having if statements by themselves and having them linked in with an else statement. So be very, very careful when you do that. That will cause endless confusion if you're not careful. So that's the selection structures that we're covering today. We're not going to cover the switch statement. We'll save that for next week. We're going to now move on to the repetition control structure, while repetition control structure. So that's the one we're going to be looking at. It's called while, and we're going to delete these for a second here, and I'm going to just rename this integer variable counter, and I'm going to have them, or we'll call max, we'll say max num. Okay, and then we're going to have the user enter max num. I'm going to also create a variable called a counter and set that to 0. And then I'm going to use the while repetition control structure and say while counter is less than max num, I'm going to print out, hi there, counter is. Okay, and then here's the issue. Here's what happens. While means as long as that counter is less than max num, I'm going to keep looping. So let's say the user enters a 10. Well, counter is going to start at 0, and while 0 is less than 10, we're going to ask ourselves, is that true? It's going to say yes, so it's going to go. And then it's going to be, is 0 less than 10? It's going to go again. It's going to keep going. So the problem is that the counter is going to stay 0, and the max number is going to stay 10, so this is going to keep going forever. This is what we call an infinite loop. Okay, it's a common programming bug. It's an infinite loop. But here's what we want to do. In order to prevent an infinite loop from occurring, with a count-controlled loop, which this is, while this particular while loop is, we want to move the counter toward the number that's entered. Okay, so we're assuming, we can assume for now that the user is smart enough to enter a positive number, at least a non-negative number. So we're going to move the counter toward max num. Now, this right here, counter plus plus, is shorthand for if we said counter equals counter plus 1. Okay, that's one of the shorthands that we can use. This is called the post increment operator, and it allows us to increment whatever variable we're using by 1 each time. So it's just a quick hand. As a side note of just fun facts and trivia, the reason that C++ is called C++ is it's a little bit of a programming joke. Since it's built on top of C, it's basically the inventor's way of saying it's better than C. Okay, it's incremented. It's got more features. So it's not just C, it's C++. So plus will add 1 every time you go through this loop. If I did minus minus, that would subtract 1. So that's just basically a shorthand. If you wanted to do it longhand, you could say counter equals counter plus 1, or you could also use counter plus equals 1. That's another shorthand. This one you can use with any number. I could say 2, 5, 7, 12, it doesn't matter. This is just shorthand for counter equals counter plus something. It's a compound operator right here. Okay, but this is by far, when you're using a control for the loop, this is the most common syntax here, is counter plus plus. So now, the first time through the loop, the counter will be 0. It'll print it out. The next time it'll be 1, 2, 3, 4, 5. And it's going to keep printing until it gets to max num. When this statement becomes false, the loop will exit, and then, in this case, we'll terminate the program. So let's build. And we're going to start without debugging. Let's type 6. And you'll notice that it is printing out the different counters at each of these times, and at each of these iterations, and we'll notice that there are 6 sentences. Hi there, counter 0, 1, 2, 3, 4, 5. Since we started at 0, that's why it starts at 0 and ends at 5. Never gets to the actual number 6. So let's try it again. Let's try it with a different possibility. Let's say 15. In this case, you'll notice that it prints all the way from 0 to 14. Okay, so from 0 all the way to 1 less than the number we entered, which is pretty much what we expect, because when the counter gets to strictly less than the max num, that is when we terminate the loop. So, this is what we call a count-controlled loop. Okay, count-controlled or counter-controlled loop, because it is based on counting the number of times we go through the loop. Right? Now, you can also use while in a different pattern. So if this is the count-controlled loop, there's another format that we can use called sentinel-controlled loop. Sentinel-controlled. It's by using a particular flag. So let's delete this, and let's say that we're going to find the total weight of a class. of students or of a room of people. So I'm going to say total weight. I'm going to set to 0. I'm going to say we're just going to have a temp variable to hold the weight each time through the loop. I'm going to say, outside of a loop, I'm going to say enter a weight to add to the total, or -1 to exit. Okay. And then the user enters some variable, and then I'm going to say while temp is not equal to -1, I'm going to loop and enter another weight. I'm going to say enter another weight, and then they enter yet another weight. So in this particular case, since the user entered a temporary number, if that number is not negative, or not a -1 in this case, I'm going to add it to the total weight each time through the loop. Okay, so if at any point during this processing they enter a -1, it's going to exit this loop. Okay, and then whenever they exit the loop, I want to say total weight is. Okay, so this is called a sentinel controlled loop. Notice it's not the termination condition is not based on counting. Okay, it's not based on counting. If I build this and say enter a weight to the total or -1 to exit, you'll notice that I kind of have it written twice here. Could I have done this all at once? Well, you could have, but we haven't really learned the structure to do that most effectively. We'll learn about that repetition control structure next week, called a do-while loop. But this is called a priming read. A priming read. That's the first time we read information to be handled by as the condition for the loop. Since we can't get into the loop in the first place unless we give it a number to compare to this, and we don't want it to use some sort of extraneous information, then we have to tell it some particular value to start with, and then it can just loop. So let's say enter a weight to add to the total or -1 to exit. Let's say we just entered -1 off the bat. It'll say total weight 0 and terminate the program. Let's run it again, and notice, let's say I have 100, and notice it'll say enter another weight, because when I entered 100, it went into this variable temp. Okay, then we tested the loop continuation condition right here. Is 100 not equal to -1? That is true, so it continues. So we added that to the total, which we haven't seen yet for this set of iterations, and then it'll say enter another weight, which is why it's saying it right here. And then this CN statement is waiting for me to enter another weight. See 150, and I'm going to keep going. 200, 220, 180, 190, 170, 160, and then let's say I'm done now. I hit -1 and hit enter, and now it'll tell me the total weight is 1370, which if we were to add up all these, we would get 1370. Right? Pretty cool. So that's the while repetition control structure. So to review again, an algorithm is a well-defined, finite, ordered set of steps for solving a problem. There are 3 categories of control structures: sequential, which is when you just write stuff in sequence, kind of like this code up here, right? Just declaring variables, asking for input, getting the input. We're not really repeating something over and over again. We don't really need to make a decision at this point. So this is just sequential control. Sequential control structures, selection or branching control structures, and repetition, also known as iterative control structures. So, the selection control structures that we learned today are the if single selection control structure, the if else double selection control structure, and the while repetition control structure. Within the while repetition control structure, we learned about 2 different ways to control when the loop ends. One is called a count-controlled loop or counter-controlled loop. That's when you're actually counting a certain number of times through the loop. Whether the user enters it or not, maybe you just want 10 test scores. You can declare a variable up here, a counter of some sort, and a max number and make that 10. I can also use literal integers, just as I am using here, saying temp not equal to -1 directly. That is a sentinel controlled loop, because it has a sentinel value that it's waiting for, and then if you ever enter that sentinel value or flag value, sometimes this is called flag controlled loops, looping, we will exit the program if they enter the sentinel value, which is -1. Okay, so these are two very common tasks for a computer to perform, is making a decision and also repeating a task over and over again. Computers are very good at repeating stuff, especially mundane tasks, over and over again. Now, if I didn't know about looping and I wanted to ask the user to enter their weight or enter different weights, say 10 times, I would have had to write cout, enter another weight, and cin temp, 9 times after this initial one up here. But with this sentinel control, I can just keep going and then wait until the user enters a -1. Probably it would be a good idea inside the loop to say enter another weight or -1 to exit, because you want to remind the user how to actually get out. So that would probably be better. All right, so that's the primary stuff we're working on today, but we're going to create a slightly larger project and integrate object-oriented programming into this in just a moment. So let's delete this stuff right now, and we're going to create our class. I'll describe the class. It's going to be a person class, a very simple class representing a person, which has a first name, last name, and an age. Okay. We're going to have all the standard get and set methods, but we're also going to have an additional method that's going to be called get status. And get status is going to tell you whether that person, based on their age, can drink or smoke legally. So, for header files, we're going to add a new item. I'm going to add a header. I'm going to call it person.h. And for source files, I'm going to add a new item, and it's going to be a CPP file. It's going to be called person.cpp. So let's start with the header file and define what we have here. Just in preparation, I'm going to include the person header file in the main file. So for this, we're going to need to include string. I'm going to create the skeleton of my class. Again, don't forget the semicolon. The public and private portions of the class. We're obviously going to have a constructor. We're also going to, for the private data, we're going to have a string fname, string lname, and then we're going to have an integer age. And for the methods, we're going to have the get first name method, and I'll also have a, oh sorry, that has to be a, yeah, there we go. We have to give it a string to set. Sorry, I'm completely confused here. Okay, there we go. String. Get first name returns a string because that's a string. Okay. I normally do the sets first, so I threw myself off. Okay, so string get last name. Okay. And then int get age. Alright. And these are the accessor member functions that we talked about before. There's one little thing that I might be doing slightly different than I did last week that I'd like to tell you about. The keyword const. Now we talked about how const could be used with variables. If you have a const int pi equals 3.14, that basically says that you cannot change the value of pi, you can't change the value of the constant while the program is running or anywhere else in the program. So that basically causes a compiler error if you try to change the value of a const. In this context, the keyword const is used by the compiler. So I declare the return type and then identifier of the member function. If I put the keyword const after it, that basically is me signing a contract telling the basically promising the class that I'm not going to implement anything in here that's going to modify any of these. It's basically read-only. It's just to access data. This is not technically required, but this will this is considered good programming practice to put const after methods that do not modify the internal data. So the next thing we're going to have are the setters. So void set first name. That's going to take a string. And notice I'm not putting const after these because these will modify the internal data. These have to modify the internal data because that's their purpose. L. You know, I'm going to put first and last here. A little more clear. Okay. And then set age. That takes an int variable. Now, the last method that we're going to write is going to be a method that basically just prints out its own data. So it's going to be void get status. And this one also does not modify the internal data, so we're just going to have it print out a bunch of stuff based on if statements. That's basically what's going to happen with this. So I'm going to grab these and I'm going to implement them over here in my person.cpp file. First I have to include person.h. And I'm also going to include iostream because I need to do that to use the cout and cin. Well, I won't need cin, but cout I will. Also remember my little trick here for getting rid of this space once I pasted it is just hold down shift and hit tab after highlighting all of those. And remember that we want to have the name of the class followed by the stream, or followed by the scope resolution operator right here. It has to come after the data type in any of the method names. Just copying and pasting these. And also, since we're going to provide implementations here, it is best that we delete the semicolon and then paste. I can paste or I can actually just write them. It's no big deal. Okay, so let's see what we want to do here. For this, let's just set the f name to an empty string, the l name to an empty string, and the age to 0. Okay, this is default. For get first name, we return f name. All right, for get last name, not surprising, you return l name. For get age, you return age. For set first name, you set f name equal to first. For last name, you set l name equal to last. And for set age, we set age equal to a, which is the parameters that are passed in respectively. Now, so those are pretty much straightforward. Those are what we've done before. Very simple, very straightforward. For get status, this is going to be a little bit different. When we call get status, what we're going to do is we're going to print out various messages based on the user's age, which has been set. So, first thing is, if the age is less than 18, we're talking United States here, so If you're from another country, I apologize for the confusion, but in the United States it's legal to smoke, use tobacco products at age 18, and it's legal to drink when you're 21. So, I know some of you teenagers possibly taking this think otherwise, but as far as legal is concerned, I digress. So we've got, if the age is less than 18, we can say you cannot smoke and you cannot drink legally. Okay, so that's that. Now let's do this. Let's say else, and I'm going to use a different technique here. If the age is not less than 18, we know that the age is 18 or more in this else statement. So I'm going to say you can smoke legally. The other thing, let's see, let's change this to this person. You know what, actually we're going to make it even better. We're going to change this right here. I'm going to actually make it print out the person's name. That sounds even cooler, right? So, this first name, and last name, and then it'll say cannot smoke and cannot drink legally. Okay, so we'll print out the internal data numbers, F name and all. So, if they get to this point, that means that they can at least smoke legally. So we're going to say, you know, Bob Johnson or whatever can smoke legally here. Okay, so that's correct. But here's my question. Just because they get to this portion right here doesn't mean that they can both smoke and drink legally, right? Because it doesn't mean they're 21 or older just because they made it into this portion. This just means that they're 18 or older. So how do we handle that? Well, we haven't learned about some of the logical operators yet, at least thoroughly, so we can nest these. This is a very commonly used technique and it's very acceptable in many situations. So I'm going to say if they get into this portion, that means they're 18 or older, right? So if they're inside here, then I can set another set of if statements. If age is greater than or equal to 21, okay, then I'm going to say and they can drink legally. Okay, so we know we at least printed out their name already. So let's do that. I'm actually going to modify this so the formatting's a little bit different. Let's do this. I'm going to delete that and put a space there. I'm going to take off the indel here, and I'm going to put an indel down here. I'm going to tell you why. If they can just smoke legally, but they're not greater than or equal to 21, it's going to say this, and then we're going to skip this part, and then we're going to do a new line. So that's going to look as if we put, the same as if we put a new line here. Now here, it'll print this, then it'll print that if the age is greater than or equal to 21. And then we'll put a new line there. So either way, it'll look a little more seamless. Okay, and we won't really be able to see if there's a space or not here. We'll delete that one, but we'll leave one right there. Okay, so I'm going to go to the main.cpp file, where we've included person.h. I'm going to say person p1. Right? And then I'm going to have person P2. Okay? So P1 dot set age to 15. Let's do this. Let's have a person P3 also. Okay. So we'll say this is the under 18 one. This is going to be the under 21 but greater than or equal to 18. And this is going to be the 21 and over person. Okay, so P1, we're going to set name as, or set first name as, we'll say Jason, so last name Johnson, okay, P2. It's going to be set. We're going to set the age to 19. P2 set first name. Sally. P2 set last name. Fudgeworth. Okay, and then P3 set age to 25. Set first name to Billy. Snuggle Dumpling. All right, now, so we've got 3 people here. We've got Jason Johnson, who's 15, Sally Fudgeworth, who's 19, and Billy Snuggle Dumpling, who's 25. We've set all the information to the internal data members, and now we're going to just, instead of printing out their ages and names separately, we're going to just call the get status method on each of these. Notice I'm not putting these inside of a cout statement because the cout statements are performed inside of the member function get status itself. So we don't need to worry about that. In fact, I could actually eliminate this IO stream up here because this is taken care of there, but that's neither here nor there. We're going to leave it for right now. Okay, so it's succeeded, so I'm going to run it, and you'll notice that it'll tell us Jason Johnson cannot smoke and cannot drink legally, Sally Fudgeworth can smoke legally, Billy Snuggle Dumpling can smoke legally, and they can drink legally. Now if we kept, well, I should probably set that to he or she, but we'll keep this as a colloquialism, and we'll say they. But it's not an English class, so it doesn't matter. So Jason Johnson cannot smoke and drink legally. This is because we set the age to 15. In the internal implementation of get status, we set this so that if the age is less than 15, if the internal age that's set is less than 18, it'll print out their first name, space, last name, and then space cannot smoke and drink legally, which is exactly what we have with this top one. And then for the second one, since the age is set to, was it 19? 18. 19? Since it's set to 19, it does fall into this code right here, this code section for the else. But it just prints out can smoke legally because it does not satisfy the condition of this if statement, which is a nested if statement inside of this else portion of this if else block here. Okay, then the final one is Billy Snuggle Dumpling, whose age is 25. Since he's 25, he falls into this else section, so it does say he can smoke legally, but he also satisfies the condition for if age is greater than or equal to 21. All right, so that's good. So that's basically what I have for you. I have uploaded different stuff to session 3. I've got the session 3 notes set here with another example inside of them, pretty helpful, and also the chapter 4 slides. I received a few questions this week that I wanted to address, and a couple other topics, just class information that I wanted to cover. The first thing was I was asked if I'm following along in the syllabus, do I need to read all the slides and read all the entire chapter? It seems like a bit of overkill. It is a bit of overkill. The slides are just there for your convenience. You don't have to ever look at the slides if you don't want to. You don't have to ever read the book if you don't want to. If you feel like you're learning the material very thoroughly, and you can do a couple of the examples out of the back of the chapters, and you can fulfill the homework that I've assigned, and you can do the programming projects fine, then I don't care if you read the book. It's a very verbose book, so I know some people have trouble with that. It's got quite a bit of stuff in it. Some of it's maybe a little bit too much. But yeah, the slides are pretty extensive. I would recommend, I'm obviously not checking it, but I would highly recommend you read my session notes, because the session notes are extremely, extremely important. and they usually summarize everything in the chapter pretty well. So if I look at the session 3 notes for this week, you notice I basically just summarize everything about what is an algorithm. I tell you what chapter we're in. Excuse me. And then I also go over a couple additional topics like pseudocode. I tell you that, you know, we could go through, before we design a class, before we design methods, we go through and we say, what are we going to do when we perform a particular action. And then, of course, I go through the main problem of today, which is the control structures. And I go through the 2 major categories of control structures, iterative and selection. So then I cover the if and if-else selection statements, which are the 2 that we cover in this chapter. I tell you the differences between them, and then give you output in the different scenarios. You can mix the numbers around and change things to see what it does. It's fine. And I show you how to modify the code so you can use the if-else double selection structure. And then also I show you how to use if-else else structure as well. So I mean, this is also considered a double selection structure because really the way that C++ views this, the compiler views this as nesting actually, but it's almost as if we were to do it the way we did it here, where we have something nested inside of here. This is kind of like nesting as far as the compiler is concerned. But you can look at it as being just a stream of different possibilities. Now, I did throw in a logical operator here, the AND logical operator. This means that both of these conditions must be true in order to enter that section of code. Okay, so finally we go over the while repetition statement. I give an example in here as well and show you what the output is, and then give you an example of putting the selection and repetition statements inside of a class. So pretty simple stuff. But I hope it's relatively thorough enough for you to be able to use this. So this particular class isn't really a well-defined class, I wouldn't say, or isn't a really well-designed class. But it's basically a functional class. It doesn't have any private data members, so don't be thrown off by that. This basically is just performs the input and output from the user and totals up a bunch of weights and then finds the average. Notice, also keep in mind that the average for weights would be a double or a float, not an integer, because you might have fractional parts for weights and averages. So, okay, and then here's how you use it. All right, so that's a pretty good summary, I would say. Because I wrote it, though. If you have any questions, I would say ask me about it. The other, obviously, the discussion board is where you should ask the majority of your questions if you can. If you have something private you need to talk about, then, or something you're embarrassed to ask, it's fine if you email me. But discussion board, I definitely check frequently and try to get back to people on this as soon as possible. The other question I had was there was a little confusion over the midterm scheduling. There were a couple mistakes on the discussion board about the midterm date, which I hence corrected. The actual midterm day is going to take place on Tuesday, June 11th. I have one morning session, 11 to 1 p.m., and then I'm going to have an evening session from 6 to 8 p.m. I would like to throw in, or find out what, if these times don't work for anyone, I want to get other ideas for certain people that maybe can't come in at those particular times. We'll work out something, so don't worry, don't sweat it. We're going to make sure something happens, or even if you have to have it proctored, that would be fine too. But my tests are really not that difficult, so even if you show up, let's say you have to make it here at noon, for example, and stay until you probably could finish it in an hour, to be honest, but if you need until 1:30 or 2, I could do that. If you come here, you have to come a little late here, you have to come at 7, I could give you a little more time then. Okay, so if it's a matter of these particular blocks don't work for you, then we can definitely work out something on those days. If you have to come sometime in between here, like sometime between 1 and 6, I'm sure we could work something out for that. If you need a completely different day, just let me know and we'll work something out. Okay, so that's pretty much those comments. Let's go to the discussion board and let me see if there's anything pertaining to anything we're having done in class. It didn't seem like there were any general questions. Okay, I'm able to make either session on Tuesday, the only day after 1 p.m. on Monday, Friday. Yeah, I'll definitely work something out for you, Kristen, and also David. I'll work out something for you. Anyone who has like some really, really strange situation going on. You'll notice, David, that I did respond to you. Again, if you could make it a little bit later for the test, even if you get there by 7, that should be fine. You'll have plenty of time to do the test. Some of you might even laugh at my tests because they're, compared to some instructors, they're extremely simple. So I'm not big on tests for classes where I'm let's put it this way, I'm more concerned that you're able to write a program than I am if you can regurgitate, some random stuff you learned in the book that, may or may not be really pertinent to the course. I just want to get some fundamental ideas just to have a test up there. Okay, so again, we'll have session 3 uploaded very, very shortly, and I'll have the video lecture uploaded on YouTube. For a couple people were still having problems viewing the video lectures. It's really not super difficult to get to it. youtube.com/profjpbaugh, my name, profjpbaugh. You can just go under here, and they're actually they're sorted under, I thought I had them under a playlist, but apparently I don't. I'm going to have to make a playlist for them. But look for the ones that say OCC in front of them. I had uploaded just some other lectures, brief lectures that I've done before, just testing and fooling around with Camtasia. But you will see session 3's video uploaded pretty soon. So, all right. So if you have any questions, please email me at jpbaugh@oaklandcc.edu, or you can go into the discussion board and have a discussion with your friends and myself. Question about class. This is basically if you have any general questions about the class, homework trouble, anything like that, unless I may make a new topic for just specifically for homework trouble, but questions about class, you can post it here for now. That's no big deal. All right, so I will talk to you guys later, and I'll see you next week. So have a good week.